All right, let's keep going here with section 1.4. This is a pretty short section. We're just going to talk about some vocabulary and then do a couple examples here. So bear with me here. So we're going to be talking about the real number system. And we've talked about rational numbers, irrational numbers, fractions, decimals, integers, terminating decimals, repeating decimals, all these different things. And I just want to put them all together for you just so you guys can see where they all fit with each other. So in the real number system, we have two kinds of numbers. There's two kinds of numbers in the real number system. There are rational numbers and there are irrational numbers. Any real number, and there are non-real numbers that you won't learn about for a few years, any real number is either rational or irrational. Okay? So let's zoom in on rational then. All rational numbers are either integers or they're non-integers. And non-integer rational numbers are fractions. So rational numbers are either integers or fractions. I'm gonna put in parentheses here, non-integers. Because integers can sometimes be fractions too. All right, and then in integers, we have, it's pretty simple, right? We have positive integers. And we have negative integers. I'm actually going to add a third little streak here from integers. What's a number that's an integer but it's not positive or negative? 0 is an integer that is not positive or negative. Okay. So the reason that it's important to know this little family tree, the real numbers family tree, is because sometimes I'm going to give you a number and I'm going to say, well, which one of these families does this guy belong to? What is the most specific family you can put it in? So let's do an example here. Let's do example A. It says use a calculator. Oh, that's nice. We don't have to do long division or anything. Okay, use a calculator to represent these numbers as decimals rounded to 3 places. 3 places. Then order them from least to greatest on a number line. Also label each number with one of the categories from the real number family tree. Okay, so let's take a look at each of these guys individually. We'll stick with this color here. All right, so I'm gonna look at 5 and 11/13 first. All right, so I'm gonna write this as a decimal. Okay, this is equal to, I'm using a calculator here. So 11 over 13 is 0.846. So 5 and 11/13 is 5.846. Please use your own calculator to practice writing these as decimals, okay? I'm using mine. I'm expecting you to use yours. Okay, 5 and 11/13, that's a fraction. So that's a non-integer rational number. Okay, I'm just going to say it's a fraction. All right. We've got square root of 30. The square root of 30 on my calculator, all right, using my calculator here, 30 square root is 5.477. Okay, so the way that it looks on my calculator, and just knowing what I know about rational and irrational numbers, This is an irrational number. Most of the time, not all of the time, but enough of the time that you can assume, if a square root does not come out to be an integer, it is most likely an irrational number, okay? And that is the case with square root of 30. Square root of 30 is irrational. Okay, we got negative 84 over 25 is the next one. All right, I'm just gonna put that in my calculator here. And I get negative 3.36 here. And since this is a fraction, this is, it's rational, it's a fraction. This is a rational number. It's not an integer though. Okay, the next number here is negative 8.283. Negative 8.283. Repeating. Oh. Okay, negative 8.283 repeating is equal to, well, it's just equal to itself, right? That's the number we're going to use. All right. And since this is a repeating decimal, repeating decimals are rational numbers. This is a rational number, okay? This is a repeating decimal. Did I forget that in the family tree? Let me look. All right, this is a rational number because it's a repeating decimal. Aha, I did, didn't I? Sorry about that, guys. Let me just add that real quick. Rational numbers, boom, also includes, it includes both terminating and repeating decimals. Terminating and repeating decimals. Okay, and now we have the last number we're going to look at is pi squared, the square of pi. And pi is 3.1415926, etc. All right, your calculator should have a pi button on it, but if it doesn't or you can't find it for now, I can probably show you where it is later. But for now, just use 3.14, and then we're going to take that and we're going to square it. All right, and what I get is 9.8696, okay? And I'm gonna round that to 9.867. Oh, sorry, 870. That's how we would round that, okay? And this is an irrational number. Pi is the classic example of an irrational number. So if I square it, it's still going to be irrational. All right, now it says to label these on a number line. And you guys, I'm not going to do example B today in these notes. So you can go and do this yourself if you need to practice. But I'm going to cross that out and draw my number line down here. There we go. So that's my number line. And now I'm going to label these from least to greatest, okay? So I'm just gonna go from lowest to highest, okay? So looks like negative 8.23 is the lowest. Negative 3.36 is the second lowest. And then looks like, all right, now I gotta decide between these two. And 5.477 is just barely lower than 5.846. And then pi squared is the biggest. All right, and I'm gonna use their original form, not their decimal form when I put them on the number line. So Lowest was negative 8.283. That's how it was written to me. And then number 2 is negative 84 over 25. And that's at negative 3.36. Negative 84 over 25. All right, and then we're gonna have 0 here. And then we have the square root of 30 is a little bit more than 5. And looks like 5 and 11/13 is just above that. And then pi squared is kind of out here. It's just over 9. So, I think I did everything it asked me to. Least two greatest on number line, labeled it with a category, yeah, okay. So if that was confusing, I would encourage you to try example B on your own. And we can walk through another example like this in class next time. But for now, that's the end.